Welcome to the Rory Academy YouTube channel. We share valuable information about power electronics technology and its emerging applications. We have a great announcement to make. Coming soon, we will launch a platform for power electronics technology-based developers. Introducing the brand new www.roryacademy.com. This will be a first online platform where the design, development, and prototyping of power electronics-based systems and products will be learnt and ideas shared through on-demand courses, webinars, tests and evaluation kits developed and sold, and a forum for the curious minds. All our YouTube subscribers will have access to 1-year free membership, which attracts 10% discount on all products. Remember, think deep, think beautifully. Today, we will be examining the structure of the Tesla Model 3 inverter to understand how it is assembled and its key components. Our focus will be on the inverter housing, along with its connectors and connections, specifically related to the placement of the silicon carbide MOSFET devices within the inverter structure. The Tesla Model 3 is a battery electric-powered mid-size sedan with a fastback body style built by Tesla Incorporated, introduced in 2017. The Model 3 was the world's top-selling plug-in electric car for 3 years, from 2018 to 2020. The Model 3 was the first electric car to sell more than 1 million units globally. Let's examine the high-voltage components of the Tesla Model 3, which primarily operate at around 355 volts. These components include 1. AC compressor, 2. Front drive unit, which can be optional, 3. Cabin heater, 4. High-voltage battery, 5. High-voltage battery service panel, 6. Rear drive unit, 7. High-voltage cabling, 8. Charge port. The Tesla Model 3 is available in 3 different drive configurations. Rear-wheel drive, which uses a permanent magnet motor. Standard all-wheel drive uses a permanent magnet motor in the rear and an induction motor in the front. And the performance all-wheel drive uses a permanent magnet motor in the rear and an induction motor in the front. The Tesla Model 3's front drive unit has several features, including 220 kilowatts peak power, 330 Newton-meter torque, and the inverter, motor, and differential are integrated into a compact design. While the rear drive unit's features are the rear motor is an AC permanent magnet synchronous motor with a variable frequency drive and liquid cooling. The front drive unit of a Tesla Model 3 consists of a motor, inverter, and differential that are compactly integrated. Some key features of the front drive unit include: the motor can generate a maximum of 295 horsepower and 243 pound-feet of torque. This design is particularly advantageous for vehicles with independent suspension, as the differential is incorporated within the motor's housing. The Model 3 uses the same permanent magnet switched reluctance motors as the Tesla Semi. Tesla has transmissions with a single speed, responsible for power transfer from the electric motor to the wheels. Hence, the gearbox is part of the front-wheel drive manual transaxle, which incorporates the gearbox and final drive into one housing. The inverter is part of the drive unit that converts the battery's 400-volt DC power into 3-phase AC power for the motor. The inverter uses a 3-phase 2-level inverter topology with 6 switching power semiconductor devices. The main components of the rear drive unit of a Tesla Model 3 are A. AC permanent magnet synchronous motor, which is the liquid-cooled motor with a variable frequency drive. B. The inverter controls the motor's speed and direction. And C. The final drive assembly includes a differential and reduction gear. Let's explore the disassembly of the inverter structure in the Tesla Model 3. We will examine three key aspects: the inverter housing and high-voltage connector, the inverter PCB and three-phase lead terminals, and the inverter PCB alongside the liquid cooling inlet. Now, let's take a closer look at these components. Let's examine the outermost part of the inverter housing, which is primarily made of aluminum. The high-voltage connector links the inverter to the high-voltage battery pack, while the low-voltage connector powers all the low-voltage components of the Tesla Model 3. The coolant passage cover protects the flow of liquid coolant, which helps dissipate heat from the silicon carbide MOSFETs in the inverter. Additionally, there is a coolant inlet through which the liquid coolant enters the coolant passage cover, and a coolant outlet from which the coolant exits the inverter system. Let's open the lid and take a closer look at the inner components of the inverter housing. The high-voltage connector slot and the low-voltage connector are both highlighted. Additionally, the heatsink responsible for dissipating heat from the silicon carbide MOSFETs, along with the housing for these MOSFETs, is also highlighted. The coolant passage cover protects the flow of liquid coolant, which is essential for dissipating heat from the silicon carbide MOSFETs within the inverter. There is a coolant inlet that allows liquid coolant to enter the coolant passage cover, as well as a coolant outlet where the coolant exits the inverter system. Let's examine how the silicon carbide MOSFET module connects to the inverter housing. The module consists of 24 silicon carbide MOSFET devices, with 4 devices connected in parallel for each switching position. Each specially packaged MOSFET device has 5 terminals: the drain, gate, Kelvin source, and an electrically isolated thermal pad. The drain, the high-voltage connection for the parallel devices, is connected to the bus bar. Furthermore, the connections between the upper and lower devices create a 2-level converter, which acts as the output of the inverter linked to the motor windings. Watch out for the concluding part in the coming weeks. Remember to like, subscribe, and hit the notification bell. Thanks for your support.